Welcome to C# for Crestron programming. C# allows multidimensional arrays. They are in essence an array inside of an array for a two-dimensional array. But what is this useful for? If we have several light loads and want to store 4 preset levels for each, a multidimensional array would be a good choice for this. Each keypad set of presets are stored in a second dimension of the array. Think of a two-dimensional array as a spreadsheet. You have columns and rows. The first number is the row, the second number is the column. You can find any cell of information by using the row and column numbers. Multidimensional arrays are exactly like that. Creating a multidimensional array in C# is as easy as the single array, except we add a comma and a second number, or more depending on how many dimensions you want. For simplicity, let's focus on a two-dimensional array for now. We can initialize the multidimensional array the same way as a single-dimensional standard array, except you load each row in its data set of curly braces. Access of the array's information is simple. We can simply use the index of the array for row and column to get the specific information desired. The same rules apply to multidimensional arrays. You cannot try and read beyond the array index limits, or you will get an exception thrown. Let's create a small program to demonstrate a two-dimensional array, starting with an empty C# console app. We can now create the array and initialize it with some numbers. Now let us add a for loop in the method to print out the contents. In this instance, we will loop through the rows and print the column data per row separately in the Crestron console printline statement. Notice that the loop starts at 0 and runs as long as x is less than 3. Remember that C# arrays are 0-based. When we initialize it to a size of 3, we have array index 0, 1, and 2, a total of 3 possible indexes. Now we can run the code and issue the command in the console. We can see the contents of the array. Each is accessed by the 2 index numbers, with x representing the row index. What about a 3-dimensional array or beyond? You simply specify the extra indexes, and if you are initializing it, you will need more nested curly braces to specify what value goes into what cell. Here we have a 2x2x2 3-dimensional array, and we will load it with values ranging from 1 to 8 into the array. We can now add in a set of nested loops to print out these array cells to see what is stored in what locations. This is an array within an array within an array, and is very useful for a data space that contains many more possibilities. Back to our lighting example. A 3-dimensional array can expand the lighting presets to go from intensity to holding color value for RGB lighting. Now each light can hold presets that hold RGB numbers. Thank you for watching.